In the world of cybersecurity, there's a huge shift happening right now in how we find software bugs. We're talking about a new approach that goes way beyond the old rulebook. So let's dive right in and see what this is all about.
You know, we have to start with a pretty provocative question, one that really challenges a core belief in how we secure software. For decades, we've put our trust in one main method for automated security checks. But what if that very method has a massive blind spot for the sneakiest, most dangerous flaws out there? So that go-to tool is something called Static Application Security Testing, or SAST for short. For a very long time, it's been the most effective way for security teams to even attempt the massive task of reviewing all their code.
So what exactly is SAST? Well, think of it like a super-powered automated proofreader for your code. It just scans the raw source code itself, line by line, looking for known patterns of security mistakes. And the cool part? It does all this without ever having to run the application. It's a really elegant model, and it catches a ton of real bugs.
The way it works is pretty straightforward at its core. It finds a source of untrusted data, like say something a user types into a web form, and it follows that piece of data as it moves through the program. If that data ever gets to a sensitive spot, what we call a sink, without being properly cleaned up or sanitized, a red flag goes up. It's just like an inspector with a clipboard and a checklist. Did you sanitize this? Yes? No? Tick.
But this is where we get to the heart of the issue. The trickiest vulnerabilities, the ones that are hardest to find, they aren't the ones where a check is simply missing. Oh, no. They're the ones where a check is actually there, but it doesn't really provide the safety the system thinks it has.
And this quote just nails it. A SAST tool can see that, yep, a function called sanitize HTML was definitely used. It can tick that box on the checklist. But what it usually can't figure out is whether that specific sanitizer was the right one for that specific situation. So you see, just having a check in place doesn't actually guarantee security. Let's walk through a real-world example to make this concrete. Imagine an app takes a URL to redirect a user. First, it uses a regular expression to check if that URL is on an approved list. Seems safe, right? But then, after that check, it URL decodes the input. The very last step is to actually perform the redirect with this newly decoded URL.
So, you see the problem? The security check happened before a critical transformation. The check might approve an encoded URL that looks safe, but once it's decoded, that same URL could now point to a malicious website, completely bypassing the security. And this isn't some made-up scenario. A bug just like this, CVE 2024-29041, hit a major web framework. The real weakness is simply in the order of operations.
This is where the new approach comes in. Instead of just scanning for missing checks, a new generation of AI-driven tools is being built to think more like a human security researcher, or maybe even a hacker. It's designed to investigate, not just inspect.
Now, what's so fascinating here is the fundamental change in the question being asked. The old way, the SAST way, asks a simple yes or no question. But the new way, it asks something much, much deeper. Okay, the code claims to be secure. Can I prove that wrong? Can I actually break that guarantee? It's a huge shift from a checklist inspector to a skeptical detective.
So how does this detective actually work? Well, it's a four-step process. First, it reads the code like a person would, understanding the entire project, all the context. Then, it narrows down a potential problem to a small, testable piece. It thinks about that entire transformation chain we just talked about. And finally, and this is the absolute key, it actually tries to exploit the potential bug in a safe sandbox environment to prove whether it's real or not.
Now, you're probably asking a very logical question. If this new AI is so smart, why not just point it at the reports from the old SAST tools and have it sort through them? It seems way more efficient. But it turns out there are some really good reasons to start from scratch.
The first reason is a problem called premature narrowing. Basically, a SAST report is a map of where that tool has already looked. If you give that map to your new AI detective, you risk giving it tunnel vision. It might only investigate those known areas and completely miss entire categories of bugs that the original tool was blind to in the first place.
Second, those old reports, well, they come with baked-in assumptions. If a SAST tool's idea of what's safe is flawed or incomplete, feeding that to the AI can change its mission from investigate this whole system to just confirm or deny this one specific alert. And that's not what you want.
And finally, from a purely practical standpoint, it just makes it harder to improve the AI.
To make a reasoning system like this better, you have to know what it can find all on its own. If it's just sifting through another tool's leftovers, you can't really measure or improve its core discovery abilities.
So what does this all mean for the future of finding security flaws? Well, it's really about redefining the roles, about letting humans and machines each play to their unique strengths.
And it is absolutely critical to understand that this doesn't make tools like SAST obsolete. Not at all. They are still fantastic at what they were designed for, enforcing basic coding standards and catching the low-hanging fruit at a massive scale. They are still a vital layer in any good security strategy.
This new AI detective, on the other hand, excels precisely where the old tools struggle. It's built to find those really complex bugs that aren't about simple data flow. We're talking about things like workflow bypasses, subtle authorization gaps, or when a system gets into a weird state it was never supposed to be in. When you boil it all down, the ultimate goal here is to help, not replace human security experts. It's about saving their most valuable resource, their time. By taking a finding from, this looks a little suspicious, all the way to, yep, this is a real exploitable problem and here's the proof, it frees up human teams to focus on fixing things, not just finding them.
And that leaves us with a final thought to chew on. We are really entering a new era where our security tools are evolving from simple pattern matchers into systems that can actually reason about a code's intent and behavior. So, as this security AI starts to think more and more like a human expert, what does that mean for the future of how we write, test, and ultimately secure our code?